So, let's get started. So as we said, we're trying to cover contract theory. So there's quite a few people here on the web. Yeah, I saw 4, 5. Not open? Oh, I forgot to. So we have 100 pages of slide today. Not sure if we can finish them all, but we will be try to do most of them. I mean, my goal, but if we can't, then we do it on next Tuesday. So next Monday, the normal makeup, we will do dynamic games of incomplete information. So contract theory, I found this topic is one of the most useful thing when you consider business application, because of in general, when you remember when you learn on Monday, right? When agent have incomplete information, right? You consider base Nash equilibrium, and in general, the equilibrium can be very complex. Okay, there can be many equilibrium. But if you allow, one agent actually design the contract to decide how the game is being played, then the model will be much easier, and you usually have a unique solution. And in applied sense, it's much easier, right? Instead of allowing things more difficult, then you just make your model more tractable and easier. Okay. So I will consider, hopefully, at least I will up to the moral hazard. If not, hopefully finish all, but at least I will finish. I think we'll finish up to moral hazard. So since the makeup class, so I just try to go a little bit slower, because I said this is an important topic and that is actually very useful. So I rather go detail in the math, right? Rather than I just skim through, because I think you'll be using it anyway. Okay, so that's why I would be a little bit slow here. So probably many of you have learned undergrad, right? Lemon market is the thing that you learn when you first talk about asymmetric information, right? And probably you would recall what it is. What's lemon, right? Lemon is the car that is turned out to be a bad car, second-hand car, but it's a car that doesn't go very well. It's a comparison to peach, right? Peach is a car that's a good car. Lemon car is a car that is a bad car. Okay, and what's the problem in the second-hand market is the seller who owns the car, who tries to sell the car, he knows how good the car is, right? He knows actually it's a peach or lemon, right? But as a buyer, you don't know. Okay, and this simple asymmetric information already would imply Pareto efficiency is not there. Means that the first welfare theorem breaks down, or even the market is gone. Okay, so it implies what we learned in financial market, right? There's always asymmetric information, right? Consider IPO, right? IPO is the seller who knows whether the company is good or bad, right? And as an investor, you don't know whether it's good or bad, right? Then that means that if that's the case, then IPO is very difficult, right? So how to solve this problem we'll talk about, but that is the main issue here. Okay, and one of the things that you see in investment banking, accounting, they are basically trying to solve this lemon problem. Imagine that is like later you will see this is kind of signaling issue there. To provide costly signal, if you're good, then it helps. But anyway, let's go step by step and okay. So let's do lemon market. Okay. So this example that you often see in undergrad. So let's review that, because we really want to go slowly, make sure that you have a concrete understanding, because all the foundational property is okay now. So we have two types of car, good or bad. Okay, and simple and make it equal number of good and bad, and turn out is not important for this assumption. And let's look the simple example. If you are the seller, right? To you a seller, good car worth $90, bad car worth 10. Okay, you know which one you have. Okay. For buyer, you don't know what you have before you buy it. After you buy it, you drive it, you know. But at least you know, to you, good car 100, bad car is 20. Okay. So the only important for this model is buyer will need to pay more than seller. Okay. Then trade is feasible, right? Trade is profitable. Okay. If under complete information, and good car is worth better than bad car for both buyer and seller. Okay. So that would be the only, if you can make it more general, you can make it all general number, there's no problem. As long as assume buyer, seller value good car than bad car, and buyer uniformly think better than seller. Okay. And that means that efficient trade, so that's the only assumption we want to make, right? And you can replace it by any number that will be working. Okay. And so in the model, we are going to assume that you can reverse it, but we're assuming the number of cars is infinite. Okay, for the demand for cars is infinite. For seller is finite. Okay, why we do that is actually I wouldn't want to do bargaining. I want the price will be such that it's set equal to, because many buyers than seller, right? So under symmetric or complete formation, the price will settle such that the price equal to how much people want to pay, right? Otherwise, there will be excess demand, right? At the point, right? And in that case, the simple is under assumption 1, it means the good car sell at 100, bad car sell at 20. Okay? If you drop the first assumption, what happens is good car sell at 90, bad car sell at 10, right? Because of more buyer than seller, so that sell at this price. If more seller than buyer, then sell at this price. Okay, so it's not crucial. Okay, and you can imagine the viewer somewhere in between, right? But that is to illustrate the point only. Okay, and if in the hypothetical scenario, buyer also doesn't know, okay, that means that everyone would think half likely is a good car, half likely is bad car. So they will trade at the half of the willing to pay for the buyer, right? Because more buyer than seller. Okay, buyer determine the market. Okay, so actually in the finance model, there's a lot, right? If the uninformed investor or informed investor is the one who dominates the market, is they decide the market, right? In the finance models or like that. Okay, so in this model, the buyer is more buyer than seller. So buyer, how much they pay is going to bid up, right? They're going to pay 60, right? If they pay more, then it's losing. Pay less will be, they will bid up, right? Because more than that, right? So at this point, no buyer is willing to pay for more, right? So that is the outcome, okay? And it simply means that this, if information is symmetric, right? Every car is being sold, okay? So that's why I justify the next slide. Why we have asymmetric information is the crucial part, okay? And one way to solve it later, we see is the main theme of this class is contract theory, okay? Later you will see what do we mean by that, but let's see why the market breaks down when you have asymmetric information, okay? In this model, suppose the case, more realistic one, the seller knows, the buyer doesn't, right? You can of course reverse it, but doesn't really make too much sense in this model, right? Because you drive the car, you know, right? It's hard to say the buyer knows, the driver doesn't, but it's okay to do it, but I don't think it's normal, right? Let's do the most natural one, but you can reverse it, the same result. So we're saying that doesn't know, so that means that only one price. Why? If two price, then you know who is who, right? Right. Assume people are doing symmetric strategy, right? So there cannot be both price. If both price, I know which is more likely than the others, right? So make it single price because buyer doesn't know, right? And easily you can see the price is above 90, okay? And all the seller want to sell, right? If good car, bad car want to sell, right? Above 90, good car of course want to sell. Bad car also want to sell, okay? But the problem is if both bad car and good car are there, then buyer only willing to pay 60, right? Because half of 100, half worth 20, the midpoint is 60, right? This is what we found here, right? 60 is the thing that if you don't know, then it's 60, right? So average value, the expected value of the car is 60, right? Because happen to be good car is 100, bad car is 20, right? You just do a lottery, right? Because more than 90, then bad car and good car there. For you, it's doing a lottery, right? Half of time is good car after bad car. So you only to pay 60. More than 60, you rather not buying, right? Because your payoff is the value of the car minus you pay, right? So this cannot be equilibrium. The equilibrium can only be less than 90. But less than 90 means that good car not there. Only bad car. And only bad car, that means that only $20, right? And or less, right? And in that case, the second-hand market only have lemons. No good car, only bad thing. So market breaks down. I mean the good car shut down, bad car there. Yes. Oh, price would be, in this model, price will be 20. Because you imagine this case, right? More buyer than seller, and there will be only sell $20, and there's only 10 people, only 10, right? Okay, because at most 20, so that is the outcome. Of course, if you drop the assumption that more demand than supply, somewhat finite, then you have to decide. You have to model a little bit more how they bargain, who to meet who. You make those assumptions, and of course everyone want only one car, right? So that's why it's slightly a little bit trickier. But when you apply to financial market, that's no problem, right? That's not an issue there. So that actually explains one thing, very famous concept of the second-hand market is only fitted with things that is not so good, right? So the market breakdown, all the first welfare theorem fails, right? Although that trade is efficient, but turn out to be of the presence of asymmetric information that makes everything worse off. Okay, so and probably you know this asymmetric information is very common in financial market or in business world, right? How do we solve this problem? So before we do that, I want to try to generalize what we have seen into a more sophisticated model, right? Before it's a discrete version, right? Good or bad, okay? And probably you ask, what happened when you have continuous one, right? Everything would, give you a little bit more favor, okay? So in this model, I have many buyers or many sellers, okay? And each car has quantity Q, okay? And everyone have cosigner utility. M is money, okay? Money plus you get a car, Q, right? So if you don't get a car, okay, then is no of this, right? So you, right? And this is money plus minus Q, right? So means that if you buy the car at price P, your payoff will be Q minus P, right? Can be normalized, okay? If you buy a good car, then you want minus 5Q minus P, okay? You can write in this way. I think this is better. So P is the price to pay for that, okay? But of course, when I write this, do note that when I write this, actually I'm writing what? Indirect utility function, right? Because price, remember you learned, price is not directly into your utility, right? So that's why you have to write in money and quantity, right? But when you put that in, you just minus P, same, right? Because you can write this equivalent. You can write this the same result. So a little bit tricky. I can just write my payoff and the P, I can write Q minus P, the same. Okay? But this is an indirect utility function. Right? So not exactly the utility, right? So I have to be a little bit careful. Because indirect utility function, right? You remember is your income and your allocation. Okay. But anyway, that is my payoff, right? Depending on the quantity, right? It's a good card like this, right? 1 minus 5Q minus P, okay? And again, I assume more buyer than sellers to avoid the bargaining issue, okay? The price will settle as the rents are paid. Okay? So owners, sorry, I should be a little bit careful because sorry, this is a seller, right? So I have to be a little bit careful. So that means that okay, I should be a little bit more careful to write that. So it means that if I keep the car, I have Q. Okay. If I sell the car, I got the price P. Okay. And for buyer, if I got the car, I will have 1.5 Q minus P. Okay. If I don't get the car, I have 0. So that would be, I think that would be easier to understand. Easier, right? And Q is uniformly distributed between 0 and 100. I hope this is clear what I mean. Is that clear now? Sorry, I mean. Okay. Now, so let's look at the symmetric information. Okay, that's very simple. If everyone knows the value of the car, and each car would have different price, depending on quality, right? The quality is then if your quality is Q, your car will show at 1.5 Q, right? Because so at the price where buyer will pay. Okay. If you don't know, then it will be actually sell at 1.5 Q on average, right? It's 1.5 times expected Q, right? Same thing, right? Right. So between 0 and 100, right? Then it's 1.5 times 50, right? So it's 75. Is that clear? So if you know the quality, right? Suppose the quality is 50, you sold at $75. If the quality is 100, the car will be 150 if you know the quality, right? If I don't know, okay, no one knows, then actually so at the average quality times 50% markup, right? Because the buyer will to pay 50% more, right, than the quality. Okay. Is that okay? So there's nothing new here, but more new thing is on the next slide. Okay, this is the more interesting part, and here we are using some Bayes-Nash equilibrium idea. Okay. Now we know seller knows the Q, but buyer doesn't know. Okay, buyer doesn't know. So how do we design equilibrium in this model? Okay, and we will more or less like a idea of what usually you will see what we call the rational expectation equilibrium, where often used in finance or accounting literature or business literature. We'll be saying that like before we go to the definition, let's see the example, then I motivate the equilibrium concept. Okay, suppose the price is 100, the highest you can imagine, right? And then we figure out that what is the equilibrium quality there, right? I don't know there, but 0 to 100 on average is 50. Okay, then we can tell them people are going to pay $75. Okay, in that case, this proposed price, is it consistent with the price they're paying? If no, that's not equilibrium. So rational expectation equilibrium simply means that you assume certain equilibrium there and look at how people behave. Is it consistent there? Okay? If consistent is equilibrium. Okay? So look at different 80, the average cost is 40, the price is 60. Okay? And if the price is lower, then average cost lower, then we need to pay lower. Okay? And the equilibrium is defined this way. Okay? This is usually you can see in a lot of finance or business. This is how you define the equilibrium. Okay. And right. So, but this is okay. Simply means, right, you look at how the price given in the market, P star, look at what is the optimal choice of the buyer, right, how much they want to pay for that, right, and whether this is exactly the strategy they put, right, it's like a fixed point idea, right, because asking how much they pay, right, and they willing to do this, right. So look at this, is under this price, this amount of quality is there. What is expected quality under this price? Okay, and this is the price they're paying, right? It's a self-consistent, right? So that is the definition of equilibrium. Okay? And that's why you often see, of course, you can actually formalize in the game, right? But many times you will see in a lot of paper, they simply define this equilibrium, okay, in the old days, right? But indeed, you should, in a more modern model, you would sometimes see they defined it explicitly. You define this as strategy, define this as payoff, right? And you can model this as a, next Monday we'll talk about as a perfect Bayesian equilibrium. Okay? You will be doing that. Everyone is going to propose to buy a price, right? Propose to buy a price, right? And given this price, you expect what quality is there, right? And then you're going to buy, or either you buy or not. Okay, so that would be, of course, in this model, there's no game, so that's why it's a more or less a reduced form, right? So you just define equilibrium. We say, okay, this equilibrium such that, okay, under the price P, okay, the buyer expects this is the quality of the market, are going to pay this much, and this must be price. So this is a equilibrium you define explicitly. Okay, and of course, sometimes this is a good definition, sometimes not, right? But at the end, this is sometimes you see more in the macro, right? This is called rational expectation equilibrium, right? Because what equilibrium will depend on what people think, right? And that means that usually this need not be unique, right? If people believe the price, say, is 0, okay, then this trivial equilibrium will exist, right? If people think the only thing they trade in the market is rubbish, yes.
About the confidence level of the market for the buyer. Because if you are confident that the market is it is not a unit distribution, so the answer will be different.
So okay, the question asked is, first is, this is subjective, it's objective, right? And if objective, everyone believe it, then you can say your belief actually following from that would be a natural, right? You would be saying that, okay, so that's why, I mean, let me talk about this and before go to your point. So in this kind of model, okay, you would try to have to make a conjecture, what is the belief of buyer to be part of equilibrium. Actually, we'll talk about this next Monday, is what is the belief of the buyer should also belong to part of equilibrium. Okay, and what we are saying here, what the belief here is, we believe that the seller have a dominant strategy or their dominant strategy such that if the price is higher than the Q, they just sell. Okay, we just assume the buyer, and we consider actually what is assuming here. Okay, in this model, it's an equilibrium such that all the seller have a cut-off strategy. Okay, the seller know their Q, right? And they have a strategy that as long as the P is higher than their Q, they sell. P lower than they don't. They are not strategic in that sense, right? And the buyer would also have a simple strategy. As long as they would buy, as long as the Q, the value they want 1.5 times the expected Q, higher than the price they buy. Okay? And they are small enough, they don't change the market, right? So the equilibrium must involve like this. Okay? And of course, they would have to think at this price, what may be the distribution of seller? That actually part of the belief structure. They believe that, okay, at this price, this much of the car will be sold in the market. Okay? And of course, there will be self-fulfilling, right? As I said, there's a bubbling thing always. It's like, if I believe that the car in the market are all crap, okay, are all zero, no one would sell anything, and they're all right, then that's done. Okay, usually the crap equilibrium or the trivial equilibrium always there, right? If you believe that, okay, right, and all the car in the market are rubbish, are crap car, right? The price will crap, and no seller will not sell. All the seller keep the car, right? And no buyer want to buy, and that's equilibrium. Okay, and what funny in this model, in particular, is okay when we have uniform, and buyers still think it's uniform. In that case, in this equilibrium, we focus on this particular equilibrium where the buyer actually follow uniform, think of uniform, and you can solve this model. The left-hand side is 75 P star, right? So this left-hand side always less than right-hand side. So only possible solution is P equals 0, right? And of course, in general, can be multiple equilibrium, right? If people think something else, then there will be. So let's see, when we change it from not so extreme, there can be equilibrium, okay? So let's see the other example. Suppose in the model that the market is not that bad, okay? The car actually go from 20 to 600, okay? Okay? Of course, as you said, belief is important, right? Is it actually the car go from 20 to 100 or not? It's crucial to this, right? For seller, it's very simple. Seller just say, I look at the price, I sell or not, right? But the buyer belief will be very important. If I believe that the market is much better than I think, right? The market will survive, right? If the buyer wrongly believe that, or someone try to convince that it's so bad, from 0 to 100, right? Then the market doesn't exist. So as you said, the belief is very important in this model, right? Just like when you learn macro or finance, right? If people believe that, that's what the bubble said, right? If people believe that the price is going to go up in the future, the price goes up, right? You can keep forever. It's a rational bubble, right? If you believe that it actually goes on, yeah, right? So that's the idea, okay? Suppose you believe, or what actually is 20 to 100, okay? You can calculate this expected price, right? Given the price, what's expected quality, right? That actually is better than that is, if a lower bound, the minimum, you're going to pay 15, right? And because of this, you can like solve the price, which is 60, right? And do note that this price depends on how people think, right? If people think like, oh, if this number change, okay, this depends on your belief, right? And of course, it does, whether this is true or not, can be based on objectively whether it's uniform, 20 to 100, or how they think, right? So later you will see next week, the belief is part of the equilibrium. Okay, you have to specify the belief. Okay, and under this belief, okay, you have the price $60. Okay, of course, this $60 may justify the belief as well, right? Based on how many people were selling the car. And in this particular example, right, you see only the car from 20 to 60 are sold. If your car, the quality is 61, you're not selling, right? From 61 to 100, actually, is not being sold. So basically, the market shut down. Even I change Q star to continuous, right? If the market is so bad, right, the variance of quality is so large, the market completely no exists, right? And you can change this 20 to a big number, still there's some car not sold, right? So basically that's why this paper, Eckloff, published in the QJE, I think RES, I forgot, RES? I think his paper actually rejected by 4 top 5, and in the 60s, right? There are not many journals, but at that time he just got rejected for this Nobel Prize paper. He got rejected 4 times in the top 5. I think end up in the last one he got accepted, but the math is not very complicated. Okay, I think basically I just basically give the paper. This is what the paper is about. So you can read the paper again. It's basically there. All the math already shown you. So there's nothing new from the math perspective. You can read that paper. Okay. So is that clear what actually the Lehman market is? Okay. I think I give the overall view is like when asymmetric information, okay, either the market breaks down or high quality things not there. Okay. And of course, that lead to some way to solve this problem, right? Especially the seller with good quality actually not very happy, right? Because I have the quality there. If around 60, I can sell a lot of premium, right? I can earn 50% premium if I'm able to tell the people what's my quality there, right? Low quality actually is exploiting the situation, right? And I'm suffering, okay, as a high quality. So there's a 2 way to solve this model in the information game, okay? And the most common one is called signaling. Okay, signaling is you're informed you're a good car, right? Owner, you try to convey the message, okay, that I'm a good car, I own a good car, and that is actually what usually the financial market do, right? That's what investment bank are doing, right? Or accounting, auditing is doing, right? Try to make sure that how to convey that I am a good firm, right? Underwriter, or you are signaling is like I would invite a very good investor, right? What we call strategic investor, to come in. They may get a lower price, but they got a good deal. But when they come, they know they look at the balance sheet of the company, look at so on and so forth to signal that, right? That is costly because you're selling at the price lower than what it should be, right? To extract the income, or spend money to have a good underwriter, good investment bank, they have to earn something, right? But by doing so, okay, this is going to differentiate yourself from the bad car. We'll talk about this in the Monday. It's called the signaling game, okay? When it's possible to signal it, okay? And that's what happened, right, in the marriage market, okay? In the Shanghai marriage market, right? The first thing you would say or you see is whether you have a house or car, right? Even that with the mortgage is okay. Why? Why the car with the house mortgage better than the one who don't? Right? Because by doing a mortgage of the car, right? Because you just pay 10%, right? Just not much more, but still you have to show that actually you're capable, right? Because if you're less capable, you think the future income is not so good, you're not willing to do the down payment, right? Because down payment, if you cannot finish the mortgage, then your down payment is gone, right? By showing that as long as costly, make that so that the poor type cannot mimic the high type, then you can do the signaling. Okay, the signaling can distinguish. So that's why actually you are doing PhD, right? You may ask why we need to PhD to do this and do that, right? In the old days, actually you don't need, right? Of course, one of the things is like the frontier of the knowledge is so deep that actually you need to do it, but now you need to convince the people that you spend your time in Hong Kong or US to do it, right? Why you go away from your family, right? Why don't you take the PhD at your hometown? Why come to here, right? Because coming here is very costly, okay? I'm going to spend this costly time, right? Come to here and do the job, then you convince people that you're worth it, right? And that's actually the big thing in economics, why we call it education and signaling, right? Maybe even the education is useless, but you're able to differentiate yourself from others. Okay, and that's the thing. The second one is called screening. Okay, screening is another phase, uninformed guy who tried to offer different contracts so that to differentiate which is which. So the easiest thing is what we learn by price discrimination, right? I want people to do the VIP or non-VIP, right? Just like the airline, right? They have a first class, the business class, and economy, right? Of course, if they order just selling the one single price, they're not going to extract most surplus, right? By setting different things, you can review how rich you are, right? Have a good product, very expensive one, they want to pay for that, right? If a single price, then probably they can't sell that much. Okay. Same actually you see when you have insurance contract, right? If I set a single price, okay, then whether the good health and bad health would join the same plan, that actually make the plan not profitable. Okay, by saying different plan, expensive plan cover more, less expensive plan cover less, require more deductible, more co-payment. Healthier people choose less expensive one. Not so healthy people choose more expensive one. So you differentiate them by offering different menu, right? So that's actually you will see in China, many schools look like this now. Okay, you have two track system. Okay, you can do the foreign track system, which you ask to publish multiple A journal, right? Or you can enter into the local system, right? Where you enter, you get tenure instantly, but you get lower salary, right? So by taking that, the school doesn't know whether you belong to which group, right? You want to be an active researcher or you want to be a teacher, right? Don't want to do any research, right? So that's a two-way, right? The school doesn't know whether you are the guy, maybe you're very capable, right? But I don't know whether you are actually want to do or not, right? So that is they give you a bunch of contract, bunch of choices, you self-select into that choices, okay? But in the class, we focus on signaling, okay? And this particular case, okay? And do note that this signaling has to be costly. Otherwise, the type that is poor, lower type can also mimic you, okay? As I said, this costly signal is considered as a auditing, investment banking, underwriting, also many things costly. As long as costly, you can do it. If not costly, you cannot. Okay? And okay, that's why people drink beer in the pub, right? Or that's why people get a lot of muscle, right? A lot of men get a lot of muscle, right? It's not the muscle actually make you stronger. Sometimes it's not, right? Excessive muscle actually make you weaker, right? But actually, you also learn that in the nature, the peacock, right? Actually have many feather, the male feather, right? It's actually not good for them, right? It's actually making heavier, not good for running. But he is saying that I'm so strong, I have a lot of peacock, a lot of feather, I'm very strong to attract the female. Okay, so that's the idea. Now we have the good car. Okay, now is everyone can do it. Okay, I can go to somewhere to certify with the cost $15. Okay, means that if I pay $15, I can someone to say my car is Q is 100. If I Q is 100, okay, and I can certify that Q is my car is active. I can say someone to Q is active. Okay? It's a precise, fully review that my quality of the car. Okay. So how does it change the model? Okay. So do note that this is a little bit more complicated. I go slower. Okay. So what happened to the price 60? Okay. My guess would be the price would be higher. Okay, because the market improved somehow. Okay, because everyone need not to use it. So, but let's see what you will see. Okay. So first, okay, we will see if your quality is not high enough, you will not use it. For you, it's already dominated, right? Because your car is between 20 to 30, right? You only, if without selling, you get this value already, right? And you can sell 50% more, right? So if you're 20, you can sell at $30. Okay, if you are 30, you can sell at 45, right? So you keep it, you get 40. You sell it, you got 45, right? So the gain at most, you can $50, right? So as long as your quality is below 30, you rather keep the car, right? Because keep the car, you get $30 of value because $30 to you. If you certify it and sell at $45, you still got only $30, right? So as long as between 20 to 30, you're not going to do it. Okay? Now we look at the equilibrium. Okay? We will focus on equilibrium that's a fractal equilibrium, which usually you will see in application many times. We focus on cutoff equilibrium. Okay? Cutoff equilibrium means the following. So this is the set of the equilibrium we are focusing on. Okay? And I think it's natural to see it, is if you're a very good car, you would do the certification. If not so big, then you don't do it. Okay, so that is the thing. Of course, if they're very low, then you don't sell it, right? So that would be the thing. But there will be someone in the middle in indifferent. Okay, that's cutoff strategy there. So let's calculate cutoff. Okay, the cutoff would be, okay, you're indifferent. Okay, if you try to sell it without doing certification, suppose 20 is people want to sell, right? 20 plus Q star over 2 will be the average quality without certification, right? Because 20 is minimum, Q star is the one that actually under the cutoff, right? Up to Q star is the one who don't certify. So the buyer would think this is average quality in the market. Multiple by 5 is the selling price in the market. Okay. Let me repeat. The left-hand side is the average quality of the car in the market without certification, and times 1.5 because it means the pain. Okay. And this side is what? If that guy go to certify, right? People know his quality with Q star, right? And he can sell at 1.5 Q star, right? But he has to pay $15 for certification. Okay? And you can look at check exactly 40. Okay? If you're 40, you're indifferent. Okay? Under this fractal equilibrium. Okay? And of course, you may ask, is there any other equilibrium? That's a good question, but usually we don't care because in apply, we focus on equilibrium that is more natural. So I think this is natural equilibrium. We don't need to prove uniqueness in this kind of situation. So usually the cutoff is a very natural thing will study. Okay. Of course, referee may jump up and ask, but forget about referee. I mean, for the moment, just focus on the main model, right? And this is the equilibrium you see, right? And easily you can see if more than 40, you will sell with certification. Less than that, you sell here 45 with average quality. So at least you will see all car being sold, right? If from 20 to 40, they sold at random, right? And beyond 40, they sell at the price, we know the price. So this is a very natural equilibrium, right? Good car have certification, bad car they don't, right? Just look at the diamond, okay? Good diamond have birth certificate, bad diamond they don't, right? And do look interesting thing, one interesting thing is, the price before is 60, right? And the price in the market with certificate actually lower. Okay, so if you do regression or do empirical analysis, so it need not be the case where when you have some things certified, the price always go up, because this price probably you don't observe, right? In the market, this is not in the market. This is in the market price. This is something not in the market, right? Because I certified it and sold to someone, right? It's not, usually don't observe that one. So this model can justify somehow, you can see when giving more certification, there, actually the market price goes down, need not be go up. So empirical result need not be the market improve efficiency, doesn't imply the price goes up. Because it's not the whole price you observe, right? Of course, you can say the price with certification, this all the price is more than that one, right? Because suppose the quality is 100, you are selling 150, right? But this price become a private, right? I talk to some guy, I sell at this, and that usually is not the market price. So the market price can go down. So that's empirical, there's some empirical thing there. So, I mean, of course, that would try to give you certain thing, right? When the market is segmented, right? The price can go down, right? Need not go up because you separate them, right? This price you can't observe. You only observe the market actually is worse off, right? Because this is in general whole price, but some people actually jump to this one, right? What you left is worse outcome, right? So you can see final remark before break, right? And you see the Shanghai marriage market, right? But now you have 非诚勿扰, right? Those kind of thing, right? Can make people jump from the overall market, jump from the market with certification, right? So the Shanghai marriage market, the quality can go bad, right? By improving the quality, right? By segmenting the market, actually the market, your visible one is actually can be worse off. Okay, so so that is the market price goes down doesn't mean the market is worse off. Okay, so that have to be a little bit more careful when you but actually also gives you an idea when you run the regression. It's not what you think, then actually information and the background to explain the model, right? Because you expect the market price goes up, right? More efficient, but it's not. Okay, because the reason is this one you can't observe in empirics. Okay. So after the break, we'll talk about how to solve adverse selection using adverse selection model. So we will do very mathy. So let's have break first. Everything will go very slowly, one by one, because you can see it's very complicated math there. But I want to go slowly because I want to make sure you know, right? Otherwise, you come here for the makeup class, understand it not good, right? Because it's a more advanced topic. So let's have a break of 15 minutes and come back, and then we'll go very slowly. Okay. Let's resume. What's time now? 3:40.
先去了那个纪念品店，然后我其实买到了。结果上就没有了。对，
我是最后一个。
因为我看的时候，就他还桌上摆着，然后他给人试，然后就好像很多的样子。
就是下午去没了。
那你们说一
average，对。
就是那个，因为我之前说那个 certificate， 它会导致 market 的 price 下降，这个市场。我想是回来再买下来，其实是刚刚结果没有。
对，因为你看不到那个社会法律和这个 price， 你面试不到，因为它就直接单买就是铺在 market 里面。
所以就是看起来我说，但其实。
它机器好。
more efficient， 这种
对，more efficient，但你就好像 measure， 因为看不到这个 price 嘛。
那这个 efficient 是怎么？就是市场效率。
看计钱效率就是看着没有。
看交易量。
交易量。
交易量上升，然后这个。
交易上升的 price 下降。一般来说，你 expect 和 market。
那些 ESG certificate 它有没有？就是 ESG 一些认证啊什么，它会有这种效果。
有啊，因为你这种的嘛，对吧？不叫你愿意对 people need to take for ESG。right， DSME。
可能一个月就不这么多，所以就是如果有 ESG， 就只卖20个，就愿意为 ESG 去。是这样的吗？现在。
是的，美国、中国不知道，但是美国老外的是。
为什么中国这么快吗？这种市场，我问你的时候信念差这么多。对哦。那他就卖了3天。
有钱就配一些戏，没有钱配一些现象。
所以是中国投资者没钱是吗？
不要对，那怎么说吧？ESG 基本上不是一个 inferior 对不对？你 more money 的应该怎么？就是他不给，就是情况对不对 ？pay more money。
怎么样的用一小步就是这个叫什么那儿？就是让他去。
对，但是如果你有钱他会 care。
所以这个就是还是钱。
对啊。中国有个付钱来的话才会 care。
那付起来这个发展太大了，没有人做。
对啊，有钱人才会 care， 但有钱人不会 care。
还有我想
只有有钱人才会 care。
这个是因为 screening，然后这个就是买家给卖家，比方说买家有一系列，如果你是这个，然后那陷入下面。
没有，他是对。
对，然后那么就相当于买家他有一部分的negotiation。
对。
那这样的话，就是跟你之前那个就是它的这个市场不就是那个卖家主导的市场？
对。
就是有一点那个不一样。
对，不一样的。
那这个。
的话，就比如说我seller说，我的 buyer 说，如果。
会不会走着钱抢一波？我觉得其实应该都是。
所以这个是在这个咱们这个可不上。我其实看那个黑色。
一般来说都是考虑正常的 model。
就正面写的一个差不多的，我没有仔细看。那有这两看就是这两个，就是叫你走的。
我看到有一个
故意第三个方式。这个为就是一方面第三个方式，
是不是
一个
个人就是
screening 的一方面
就是黄色。
对，但是我知道，就是那比方说这种 design contracts， 它是有成本的。
有点像
在现在的它是有成本的。
你拿着了吗？
我们做 moral hazard 都是做。我们今天讲。
好好看看。让我看看，我都不知道。
然后我现在
这个我们就下一节课。但是我们这个课。
先不买了，这样。
主要是想问一下，我担心我之前在问2家给我买，然后我下次因为再去的话就会结构估计，就想问一下，就会被他发现什么？没有关系，他应该是个就是 structure estimation。
是啥号？我得买差来着。
就是这个像这种红印的这个，那我看的时候就是一个命题嘛，就比方说在什么时态，然后跟现实的那个数学在里面。
我还跟我男朋友说，我说我下午想买这个。我还跟我妈说，我说妈，我说你带一下，然后他不会骗我的吧？
对。
那不至于吧？其实我也要是吧？在大一码里面，因为你手其实是差不多。
他们都是一个 estimate， 非常 contract， 很多来说，我觉得应该是
那你能试的就是 M 和 R， 我不知道它是因为L 是卖完了，还是因为就是没办法。
他们当然
我觉得
你做的没有，自然是方面。
S 都卖完了，那是上一次
都在好一个都没
就是因为上次有一个人大概10月中的
后他就
这就偏向
只有 S 了，
都有
是 S。我刚才记就是
那可能真的是愿意教我们。
就可以，这个是会关什么？
我知道
说关什么不重要，我们同事也
是课题，然后老师让我去测试，
然后结果那个，
所以说我传统我不能什么都懂。
有一次后来也太荒谬了。哦，学姐给你写了一个，就是那个母校的学姐给我，一人发了一条。干嘛？收到了，他是去7楼，就是学妹给他测的。让我们照顾。
不行，你看人做不动。这个。
这就我等会儿还得走，因为他是最开始都是对下的我没测出，因为他本来是下午有课，然后他是分时间让我去测。
就他的课最开始我刚才不是20，20。
我想我得下课了。所以你是按学生的方向去，就是觉得这难点。
对。学习一下，对，舌头有一点，对，多说一下。学生要做很多
阅读一点。
对，阅读一点，我可以看一下学生
那你们这边什么经济学博士有发表要求？
没有。
哦，对，没有。我们发出来的话，已经就有6、7年。因为我们审要3。我们翻译成那个 cycle 有3。
没有，有 management 好像是这样 ，management 可能要1篇。
就有那个刊。
哎，他们很快。
哦，对，他们很快。
为什么 management 很快？
他们是不是时政方面的？
因为他只能从你的公司来做你的公司的 management，across 它整个 vertical， 所以他有公司有个硬件的那个 management policy， 还有一个做法，积极的发展是直接的吧。他们就是类似于 case study 的，就是一个类似于 case study， 类似。对经济的方面要求，小公司要对general 来的发，都去学的，没办法，这个地球的学。但是我觉得这个很有用的，好像是在什么话题都反映特别有用，每个门口很有用，所以我再找一找。
这个也是必修课吗？哦。
它是硬。很主动的，就是因为人都过来。
哦，对啊。
没有 credit 也没有分数，没有考过来下。
没有，因为我线上听我就会想睡觉。
对，
困扰了。
线上会走神儿，
对，而且就会玩手机，
家里太舒服了。
对啊，肯定另外这个是啥考的这个考虑的这个地方就来了就会觉得就是behavior的嘛，来了就觉得这个3 course 的是来了，必须要听对吧？听了就会一点。所以如果我天天来办公室，我来办公室1个小时。非常。对，回去1个小时，每天花2个小时来睡觉。但是我来了就很紧张，那就是这样。
很开心。
我的办公室。
对，每天都来好好干，很开心。当我读硕士的时候，第1年就在上马会的，第2年就做那个做的太舒服太开心。
太开心，我还没体验过这种感觉。太开心，
做的太好，我也没有。
你做外面的？
他在学校。对，我在。
那是很开心。
没有啊，因为我住在山脚下。其实我过来的时间也是只有20。
上马会那个地方。你住在上马会那个地方。对，上马会差不多。对，挺开心的那个地方。
是吗？没有感觉。回到家一个活人都见不到。
所以你是来见活人的是吧？
然后憋死了，每天都想跟门口的保安聊天。
没有人那时候住的地方。这边很多人啊，学校。
是很多人嘞。
平时都很满的，可能10点钟就还有人在，晚上7点钟还有人。
啊，空调都不开了。
就是我们这边的7、8天。
真的吗？
对啊，我们这一层这个ON 的都在。
是
10点钟。晚上就到了。
你又不在，你说的好像要看的样子。好想去看一看。
可以看一看，9点钟还在，9点钟的，最后都10点半就看一下，
我感觉12层5点以后就没有人烟了，灯都关了。
都很多人。
真的吗？
那就可以来一下看一下。
看懂了。为什么你那层没有人？不知道，因为门都关着。我们那层真的好像没有人，就是因为那个灯是声控的，楼道的灯。我很多时候出去就灯都关了。
我们就很多，反正我都在。
认识另外一个老师也是住在香港，也是过来了。
但我觉得今天开心，今天就别嘛。反正你中国人每个小时都会用得上，反正是IT期间就用来做到累就做这个起来。早上困的，然后回来继续。咖啡。都。
忍住了，买了茶。
我休息了，然后再睡觉。今年。还有2000。
空气污染比较严重。
对。
反正它是说应该是多久了 ？DSE 也算了。好神奇。
DSE 跟反映什么对吧？也是要反映的吧？DSE反映什么？不是很好搞，把一点啊，再低一点。
什么？
把 A 卷都点了，
你们这边 A 就是哪儿？B 都有台。
不知道，我又没听过。
也多了。你看历史吗？看历史就是随便看的。专业历史。
你们你是说那个 ABS 3星那个？
也可以吧，我觉得第50这个 A 分嘛，BBS DD 24。
那个好难呀。
真的是 A 吗？
那个就是 A。
Top 3嘛。Top 3也要4、5。
你们只投空？我就是投啥我写都没写。
他们
我们比较重视的是。
Top 3还有2个 RF 和TFQA 是 A-。TFQA 跟那个 RF。最经典的它 RF、AS 或者 Review of Finance 6是 Pricing， 所以 A-、B+、后面的很多都是 B+、B。
但是不是那个需要发展？
这里没有这个2然后
没有哎，我那天看到法科有一个今年的上交的 market 的那个就是不是，它有 RES 的那个。
现在就是如果你没有个2然后的话，上面都是。
对，不可能，根本
连2然后都没有可能。
那你当时是什么案啊？
当年是聊两个 game 这个这样的。game 这个一个卷我现在今天不行，我现在只有这个行不行？现在还要
越来越卷。
现在越卷。对。现在基本上人手一个 A 没有2的就那不一定。你要找好像尽管是国内你要找个60-70万的需要对 A 级。深圳这个的时候。
深圳大学也这样吗？
678对。这选高中生，虽然大学是800这个北京上海，
好像是深圳政府给钱，一直在
深圳是应该是现在应该是像政府给到的，
不会的，
真的，深圳政府的钱，你不就是你不算一些非常 top 的北大清华那个 business school，
所以进深圳大学也需要那种 top 3的。不能那么绝望，机会渺茫。北京的大学那么多，你不去这个还可以有其他的。
美国人老板就跟我说，你就看那个1月份来做 top 的要被谁知道啊？很有看的，大家会看一下大概是。
但是他们感觉来的都是美国毕业。
对，美国毕业也是有东西没有那么中间。因为你见到，因为在一个上马的地区，他们都有 cost business， 那是我今天没办法。今天太多人有这个了，那边今天都不会说这些。
是已经要发表出来还是？
没RR。
那如果 RR 就会被
不重要，
没关系，
只要有过就行是吗？那比方说我现在被拒，不是，比方说现在我有，但是一个月之后，对啊，1个月之后我被拒了，那我就不能写那个 RR 了。
但是别人又不知道你被拒。
那这个事情就是我曾经有过就好，我曾经收到过
in process。in
process 等于 RR。
因为 CV 还没 update， 还现老 CV，
所以就说自己 CV 没有及时 update 得到是吗？那在面试的时候他会问你啊？但
是最后可能他会问你那个 status，
会问，那还是。
但是你是不是有面试机会？
对。面试机会有什么用啊？
可是你的面试会能说服人家觉得你是厉害的是可以的，但是你如果没有RR的经验，就是兼职嘛，因为大家都太忙了，几个 signal 的，你没有 signal 的不行的嘛。你刚刚会学了吗 ？Lemon market。
所以今天这节课很重要。
cost 呢 signal 啊 ，cost 是 produce 的，RR 是什么？你要 cost produce RR 的话，我现在 signal。
听着不对劲。
明白吧？So, come back. So, we still have 9 people here. No, not gone away. Sorry. Hopefully, you're still awake. Today a little bit cooler, but hopefully you feel less sleepy. So, we look at adverse selection, and then you have time to look at moral hazard. I think we should have enough time. But so let's look at the model, okay? It will be math heavy, so I go slowly. So any question, just ask me. Because if you are stuck somewhere, then you don't ask, then you're stuck for a very long time. Since we have a relatively small class, just ask. Okay? It's not in the exam, so just ask, right? There's no losing of any point or whatever, okay? So the setup, okay, we focus on the simplest model. So in case you are in doubt, you can look at the book I should tell you which book you look at when you get confused or you want to look further. So there are many textbooks for the contract theory. I recommend, highly recommend. Which book I highly recommend is the book that whether here. Wait. The book I recommend, not here? How can that be true? Okay, it's here. This book, I really recommend you to read this book because I use the same notation as the book. Okay, and this is the book that is very good to read and you will get a lot of insight. Okay, of course, contract theory is so common that you see a lot of calculation in other books, but this book actually gives you the intuition, which I try to give you. But if I fail to convey it, you should read that book because this book I would say is easy to understand.
The other textbook in in concept as well, but you can read that afterward. I recommend you read this first. Although the notation is a little bit not friendly, but I guess since we cover using the same notation, that hopefully that make you feel easier when you read it. Okay, and let's go. Okay, so this model, as we said, adverse selection. Later you will see the model we have usually is adverse selection moral hazard. So the difference is adverse selection is hidden information. Moral hazard is hidden action. Okay, and usually is both would happen, right? Is the guy, I don't know whether he do things or he had hidden information, right? And which thing would fit the model better? You use the which one. Okay, of course, there are models that combine the two together, but you will see it's so complicated. Okay, so you would, for your application, you will only focus on one will be sufficient. Okay, and you will see not much difference though. Okay, moral hazard tend to be more easier. Okay, you see adverse selection slightly more complicated. Okay, in terms of the solution. But anyway, let's go ahead. You see. Okay, the model is very simple, right? Usually, you see concept theory, people will talk also about agency model. But agency model means you have principal agent problem. You want to do things, but you don't do yourself. You delegate to others, right? But you don't know that guy is good or bad, right? Or capable or not, or he do bad thing or not, right? There's always concept theory problem, right? When you need someone to do it for you. Okay, so just like standard modern corporation, right? The owner and the management are separated. The employer, the employee are separated, right? I need someone to work for me, right? Then it's delegate, right? He can do things. Okay, so the question now, I use the outsourcing story, same as a textbook, right? A firm will need someone to do that for him, okay? And I actually don't know what kind of stuff he's doing, right? So I need to delegate Q to him, okay? And so look at the payoff for the principal, okay? The payoff, okay? To produce Q unit, okay? The surplus the firm would get is S of Q, okay? Normalized, if you have nothing to produce, is 0, okay? And we assume this is higher quantity, you get more surplus, okay? And this is a increasing and decreasing rate, right? And later you will see if I don't have this, I have no optimal solution, okay? Then you have assumed some boundary condition, right? You will produce infinite quantity. So later you will see, okay? But this is only, this is important to make sure that you have an interior solution for the optimal quantity. Later you will see the result, okay? And production requires fixed cost F, which will normalize to 0 at the end, but this is just trivial thing, okay? And the only thing that is a little bit complicated in this model is marginal cost of the agent is either low or high. Okay, theta low means low cost, theta high means high cost. Okay, so this is the only thing that matters. Okay, here I have discrete low and high. Okay, and actually this will, for your application, this is sufficient because you will see if you consider continuum from 0 to 1 or anything from lower bound, upper bound, the model will be very similar. So usually for application, for basic application, you just need to focus on high and low. That will be enough. Okay, of course, you can do it more general, but the intuition even will not be different. Okay, and as a standard, we'll assume the low cost V, high cost 1 minus as probability, right? So, and the cost of production is fixed cost plus theta times Q. Okay. So later you will turn out to be important is how this uncertainty, the spread delta theta, will affect the nature of the market. Okay, as we see, remember the adverse selection model, right? If this is very large, the market breaks down, right? If uniform from 0 to 100, the market gone. If 20 to 100, there's something there. And you can imagine the contract will crucially depend on this guy, right? Because of course, also depend on V as well, but this is very important, the delta is how the difference is. Okay? Later you will see. Okay? So this is the setup, and the notation is same as the book, so that's why may not be very natural, but this is the book they use. Okay? So that I use it because to make it easier for you to read the book. Okay. So now this is the contract theory of contract. So contract theory means that the firm is a principal, right? He wants to delegate the job to the agent. Okay, but the agent, I don't know if he's high cost or low cost. Okay, so what he do is he will set a payment T conditional on the Q. So it's more like a screening thing, right? It's just like he set a contract and then he will engage. He move first. Okay, and this is very important. Is what is the set of contract I allow? Okay, in this model, I just allow the contract to be a payment based on production quantity. In this model, is very natural. Okay, I allow any form, right? I allow T, right? It's negative. I have a very flexible contract, right? Sometimes I only restrict to the idea, not in this talk, but sometimes I can only allow the contract to be like linear, right? Maybe I have allowed, say, A plus BQ as a T, right? Linear contract. Or I only allow contracted contracts, so on and so forth, right? But in this simple model, I can allow very flexible contract. Okay? And why? Because only two types. That means that I only need two types of contract only. So that's why I don't need much restriction, right? And okay, is that clear what we are doing? Okay, so the firm would be choosing a very flexible thing, right? For every, basically the function, right? Because at the end, the firm can able to observe the production, right? So basically is the firm would say Q is from 0 to infinity, right? I say my payment is depend on the Q, what's my payment? Right? I can also allow negative, so I can go down. Right? It's a function, right? So it's just like for every Q, I give a T. So that is the model. Okay? I don't even require continuous. Okay? So everything is free. Okay? So I don't put restriction. But in application, your application can be very complicated. Then you may have to impose some linear restriction. Okay? But later it turned out to be, later you will see, actually I just need to specify two things is done. Okay? I need to specify what's the Q, this, and the Q this, otherwise I get 0 for everyone. That would be sufficient. Okay? But later you will see. But for now, it's very simple. It's very general. Okay? Now this is the timing that you would write the paper. And maybe you see a lot of paper, you'll be like this. You often see like this. Okay? T equal to 0, what they do. T equal to 1, what they do. T equal to 2 and T equal to 3. This is the thing you often see in papers. Okay? Later you study papers, this is what you will see. Of course, I write down bullet point, but this is what you will see in the paper often. Okay? Not in the form. And first is agent would know the type. Okay? The nature act first, right? Same as what we see in the base Nash equilibrium, right? The nature decide high cost, low cost, right? And the P is the principal, okay? We design contract, okay? The contract can only take, you produce this much, I pay this much. Okay? And now here, contract theory has a very interesting thing is the principle of a contract, and it's a take or leave it. Agent is not allowed to say, what about the other contract? No. he is only to say yes or no. What does that mean? It means that all the surplus is obtained by the principal. Okay? And this is actually do not lose much of generality in the sense that we can only focus on efficient contract, right? And the surplus can be somehow split among them depending on bargaining power afterward, right? So if you care about efficient contract, that's fine, okay? And that would be the thing we focus on, okay? If we allow bargaining, the model will be very different. Okay? But we focus on the case where this is standard, so I don't want to against the universe of the literature, so this standard thing we see. Okay? But do note that here we have a implicit assumption where the principal have all the power. Okay? And the contract execute, the payoff realize. So basically 0 and 3 is redundant, right? And 2 later you will see will be redundant as well. So the main thing is just 2, that's time 1. Okay? Because time 0 is nothing, right? A, you see time 2 later, you see we will make sure that the agent will always accept the contract. Okay? So design the way, and that's why only important is just t equal to 1. Okay? We design a contract using backward induction. We focus on equilibrium that usually we require all the agent to accept the contract. Okay? And that means that only t equal to 1 will be only meaningful thing. Okay? So we will soon tell you what is, but the only key is this one. Okay? Because they all accept the contract. Okay? So now here we focus on, as we do the lemon market, we assume complete information first and look at the case where incomplete information, look at how the contract being designed, and then we will see. Okay? And see what's the optimal contract. So the first thing is very simple. It's a benchmark model. Is I know that suppose the firm can see the type of the agent, right? I know the firm are outsourcing. I know the worker, right? Or I know the outside firm is a good high cost or low cost. Okay, so that means that the firm, so the principal can design contract for every type, right? High type was a contract for you, low type was a contract for you. Okay, so what contract we want to design is standard marginal revenue, marginal cost, right? Because the payoff, right, is S, right, to the principal, S, right? It's S, right? And the payoff is Q, right? Right? The principal is going to max minus T, right? T and Q here. Maybe I should write it down here, right? So this is the design, right? And I have to design in such a way that this agent want to do the job I do, right? That means that I have to make sure that the T is at least as large than the cost of production, right? C of the Q, right? Given theta. Maybe I should add that back to this slide, right? So I know the theta directly, right? So I design a contract, Q and T, okay? I know the theta, right? So the theta is no. Okay, I know the theta, right? I know whether I'm facing the high cost or low cost. Okay? Subgame perfect, right? I know who it is, right? I'll design a contract to maximize my payoff, right? Which is, this is my payoff for action Q. This is my payoff of a payment, right? And I want to make sure that, because this is take it or leave it offer, okay? I make sure that the payoff of the agent would be non-negative, right? Because I assume also option is 0, right? He got the payoff, the agent got the payment, got the T, he produced, he had to pay C of the Q, right? So And this will hold equality at optimal, right? I don't want to pay more than I need to, right? With equality, right? So that means that as the principal, I actually solve this guy. CQ minus this is Q theta, right? Minus Q theta, right? Because then no fixed cost, right? SQ minus Q theta. You solve for this, right? Q star equal to, right? S prime Q. Is that clear? Right? So that's why you have this line. Is that clear? Maybe I should add back. I should add back to this to the slide because I think I just a little bit lazy on that part. But you now know what I'm missing from this slide, right? Because I know the theta, right? So I can exactly say if you're high cost, my payment will be just linear to your production times your cost, right? If your cost production is 1, I will say my payment will be 1 times your quantity. If I know your cost is 2, which is high, it's 2 times the quantity. That's it. Okay. So that would be that, right? Is that clear? Now the surplus will be the social surplus will be this minus the cost, right? Same. Okay. And you can easily see without even think, right? If you're low cost, right, the quantity produced is more than the case of high cost, based on. That's why you need this S double prime is negative, right? That's derived from that, right? And for this one, okay, you can show that the surplus, the social surplus of the high is actually higher than the low cost one. Okay, and the proof is okay, like this. Okay, this is equal to that. That's fine, right? And this higher than this because this is lower. I think this is wrong. I checked this out. I think this is have to be reversed. I think. Okay. So let me rewrite the right correction. So it should be like this. Okay. I think I reversed the upper bound and lower bound here. So. Okay. I'll check it out and get back to you with this one. Okay. I'll check back this one. Or I'll do it. I'll let you know this one. Okay. I'll let you know whether I do it right or wrong for this one. And now I'll get back to you for this one. But I will focus on the case where you have income information. Okay. And we don't talk about this directly, but there's what we call later you will see if I have time to go over, it's called the value relation principle, where there's no loss of generality to say in the contract theory is we only need to design a contract for each type. Okay, that means that we only need to worry about we have to, instead of making T and Q a function, we just tell them, okay, we decide a load type, I give a contract, high type a contract, such that load type choose the contract you design, okay, and that would be the optimal. Okay, we will tell you why this is true. Okay, but we will define under the low cost. Okay, this is the surplus they has. Okay, and the key is here. The expected payoff for the principal will be the probability you meet the low type and probability you meet the high type. Okay? Because this is the surplus minus the payment. Okay, so this is the payoff under this principle, right? Under the, suppose this is a contract is in equilibrium, this is what you get. Okay. So how can we make sure this would happen? Okay. Is we require to the principal, okay, to maximize this payoff. Okay. And there will be two types of constraint. One is called the incentive competitor constraint, which require that low type don't want to pretend to be high type don't want to prevent the low type. Okay, that means what? Simply said, they do the contract, they're happy to remain the contract you design for them. They don't want to pretend other thing. Okay, high type do the high type thing, low type do low type thing. Okay, so let's see. It's incentive compatible if low type do take the low type payoff, produce the low type thing better than he take the high type. Okay, same here. For high type, he take the high type contract better than take the low type contract. Is that clear what it means? Okay, let me repeat. Incentive compatible is saying that the agent, he knows who he is, he actually do as the design, he want to do as he described, is no gain from doing other thing. Okay, basically it's like it's a subgame perfect idea, right? He designed a contract, he just follow it. Okay, just that's why the contract fee is design the contract such that they do what as they said, right? It's a dominant strategy, right? Weakly dominant, right? At least they would follow, right? Is that clear? So the other type of constraint is called sometimes you call participation constraint, sometimes it's called rational constraint, IR. Individual rationality. Okay, it simply means that low type do take the contract then stay out. Okay, and high type also do the same. So make sure that he's not more than less than 0. Okay, 0 is we define outside option. Okay, it depends on application. Application can be here outside investment opportunity can be non-zero. Okay, and pre-zero just normalize. Okay? But in some case you may have more than something. Okay, because here the high type low type share the same outside option, right? But in general can be different, right? Maybe only high type have outside option of something else, right? Is that clear? Now, let's see this example here, okay? So once we have this, we are concerned this problem is the principal, he who don't know who is facing is risk neutral, right? Either V of this, 1 minus V of that, okay? And here focus on the risk neutral guy, risk neutral principal, right? If you have risk averse, then the model will be very complicated. Okay, and subject to 4 inequality, right? If you know the math, okay, you can actually solve this conductor because everything is linear, right? S is a quadratic, right? So conductor is a way to do it. Okay, if you really got the math and you can do conductor to crunch it. Okay, it's not something complicated, but you will require you solve several pages of A4 paper to solve it. Okay, and of course, we have to use economics, make it model very simple. So don't worry. The way we solve it, we don't solve conductor. Okay, we will actually try to argue it in a very simple manner. Okay, that's why I suggest reading Lafont, because they just solve it without going to conductor. Of course, you can do conductor if you have more complicated constraint, because this is the standard constraint you have. But in your application, you may have other constraints as well, right? But usually this is the constraint you see in the model. Okay. So how to solve this? That looks crazy. How can we solve this model? Okay. The way to proceed. Okay. There are several ways to proceed. Okay. I tell you several ways. So the first way to do, usually you can see in literature or when you have many constraints, is you first assume some constraint is binding. Okay? You assume some equality for some constraint and ignore some constraint and solve it. Okay? If you solve it and check if those constraints omit satisfy, you're done. So this is standard technique you do it, because without solving a conductor, of course, so conductor can always solve the problem, but sometimes it's very complicated, right? So the thing is to do is you assume certain constraints satisfy equality and put it back and solve the model. If it's done, it's done, right? If not, then you have to hold other constraint. Okay, so that's why sometimes they solve the relaxed problem. Okay, and actually happen is like you take away the constraint, solve it. Okay, so that's standard. But we'll do other way around. Okay, what we will do is to rewrite the following. Okay, we write it, the U lower bar is this guy. This is the surplus of the agent if you're low type. Right? This is payoff of the agent of low type. Right? This is payoff of agent high type. Okay? And we define this is information rent if agent. What it is this is the payoff of agent, right? Also option is 0. Right? If complete information, the payoff is 0. Right? But if the inconfirmation, this is your expected payoff. Right? This is the rent that you get because information asymmetry. Right? And usually this is a measure of the efficiency of the market, right? It's how bad the market is, right? If the market is efficient, this is 0. Right? Because the surplus is extracted by the principal. Because of information asymmetry, you gain something. Okay? So this is this. Okay? Now with this, we can rewrite certain things. Okay? First, you can rewrite this as the following. Okay? How we do that? Let's go back a little bit because I want to be slowed down here. Okay? T bar and T bar. T lower bar is T bar, all right? T lower bar is U lower bar plus theta Q. Okay? So maybe I'll write it down here to make sure that how I derive that, right? Let me do slowly, okay? Because that will be important to derive it. So what we have is the payoff will be SQ minus T lower bar, right? 1 minus V SQ upper bar minus T upper bar, right? That will be original problem. And remember, we have just said U upper bar is T upper bar minus theta upper bar, Q upper bar, right? Let's rewrite this is T upper bar is what? U lower bar plus theta, right? You write that. This is okay, right? And you put this T into here, right? You just substitute T, right? Into this one and this one, right? T lower bar is what? T lower bar is U lower bar plus theta lower bar, Q lower bar, right? T upper bar is U upper bar plus theta upper bar. Is that okay, this one? So you just put this in here and put this in here, right? So what you get is what here? This right is expected social surplus, right? Social surplus, right? Basically, what the principal doing is maximizing expected social surplus minus expected rent, information rent of the agent, right? Right. That's very simple, right? It's what the social get. This is what the agent get, right? The difference is principal, right? Because in this world, right, either principal or the agent, right? And the IR constraint is very simple, right? Utility more than 0. The only troublesome is this guy. Okay, let's write that down to derive it. Okay, remember what the IC said. IC lower saying the lower type get this one, right? And his low type supposed to do a low thing, right? But I don't want him to pretend to be high type, right? That's the model, right? This is the IC upper bound, right? So how you can rewrite this to here? Just put that in, right? So let me do this one because I think it's important. Okay, and it's U bar minus plus U upper bar Q upper bar here. Sorry, is U lower bar plus theta lower bar Q lower bar minus theta lower bar Q lower bar, right? And this upper bar is U upper bar plus theta upper bar Q upper bar minus theta, right? So this is the T hat, this is the T lower bar, right? Is that clear? Okay. And as you can see, they're the same, right? So this cancel out. This is gone. And this, you collect the Q bar. This is guy. Can you see that? Okay. And for this one, the same concept. I'm not going to do it, but you can see how I derive that. Okay. So from this, actually we can, even without doing conductor, we can use economics to see, or some intuition to see what will be the solution. Okay. Now, how to argue this, how to solve this model? Okay. First, look at, I'm choosing U. Now I choose U upper bar and U lower bar and Q, right? Not choosing T. U is my choice, right? Because choosing T is choosing theta anyway, right? So T is a, and for the principal, higher U is worse for the principal. So I want to make U as low as possible. Okay? The lowest U you can go is 0. Okay? Or I want to make it as low as possible, right? So the first argument is U small good. Okay? Second, U must be bigger than 0. Come from this 2 guy. Okay? And the third one, look at eyes lower and eyes upper. Okay? This plus something, this minus something. So you can tell me U lower bar bigger or U upper bar bigger? Why? That is, right? Because come with this one, right? Because this is more than that, right? So we will make the lower bar 0. Upper bar will be equivalent to delta theta Q bar. That's how you solve it. Okay? Now, set to the upper bar to 0. Lower bar exactly make the IC whole. So how do you solve this? The argument will be upper bar 0, lower bar will be that would be what we're trying to do. Right? Because by doing it, actually it satisfies all the inequality there. Right? But if I do that, satisfy this, right? Everything satisfied. Actually, this is redundant. Right? So basically this satisfy, put it back, you can solve the model. Okay, let's see it. Okay. So that's I argue. Because to make it as small as possible, the only thing you can go is to go to that, right? Because why I argue this is, suppose U bar is positive, right? Because U lower bar must be higher than U upper bar, right? That means that I can have some way to reduce the both, such that without breaking so the idea is like this, okay? The idea is like this, okay? Look at this inequality. Okay? If this thing doesn't hold, strict for lower bar, what I do is lower the both, okay, without violating any inequality. So at the end, you will end up in only this result. Of course, if you don't believe it, you can do conductor, okay? But that is only economics tells you, right? You try to reduce the rank of the high cost type, okay? The low cost will just reduce to that. And once you do that, it becomes this. Much more simple, okay? You just have two variables here, right? So much very simple. You just differentiate lower bar and upper bar, right? You differentiate the lower bar, only this and this. This is upper bar. That's just the first part. That efficient, right? The choice of the lower bar, efficient one. The choice of upper bar is just below it is this guy. Oh, I forget this redundant. Okay. And you can see for upper bar guy is this one plus this guy. Okay. And the interesting part is this is efficient outcome. Right, this is efficient. And this is not. Right? And remind yourself that this is what? This is Q star, lower bar star. The first item. Right? And what is it doing here? Okay? Look at the economics. If you are low cost producer, I'm actually induced you to produce efficient one, which is more. But if you are high cost producer, I actually ask you to produce less than the efficient one. Because as this is higher means this is lower. Right? I actually ask the efficient producer to produce as efficient as you do, but you are less efficient, I cannot ask you to produce as much. I can only ask you to produce less, okay? And because of you want to pretend, so that is the problem. Okay? Ask you produce less. Okay? And probably you ask why this thing happened. Okay? Let me see if my slide have that. Okay? The slide is here, okay? That's why I've said, right? The payment to the upper type is efficient, right? Payment to the lower type is to pay this, and there's some information ran here. Okay, so being a better firm, you earn a little bit. Before it's zero, right? Now, because information asymmetry, you are a better, more efficient type, you actually get some rent, right? So the idea is, right, you just left the guy who is inefficient, have no rent there, okay? But if you're an efficient firm, you get some rent. Why? Because the efficient firm can pretend the efficient one, but not other way around. Right? The efficient one can always do whatever the inefficient firm do, right? So that's why inefficient firm can earn zero profit there, right? I make the efficient earn zero profit. The efficient firm must earn positive profit. Why? Because the efficient firm can always do whatever the efficient firm do. If I don't give him some profit, then he can just pretend to be the inefficient one. The agent, yeah. Because the agent can always, the low cost agent can always do whatever the high cost doing, right? Because he has actually, the cost is hidden, right? So I can pretend to be take the high cost one, right? High cost, then he can earn some profit. So regardless of what, we have to give some profit to the guy who actually is more efficient. Okay, so that earns some rent over there. Okay, the inefficient. Then how to make this thing happen? We have to make the inefficient firm produce inefficiently. So ask the production less. Okay, to make sure that the efficient type don't want to pretend. Okay, so that is the main result from this model, and turn out that this is very general. Okay, it's basically the most efficient type. Okay, always have profit, and there's no distortion at the highest type. Okay, and that happens when you have continuum of type. The result is always like this. Let me repeat the statement. The high type, or the most efficient type, more efficient type, extra surplus. Okay, there's some rent, being efficient, because I always can pretend something else. Okay, and when the firm want to make sure that the best type, the more efficient type, would do efficient thing, and to make them not to pretend to be, then have to make the inefficient one more inefficient. So this is general. So if you change to continuum, then the same. Okay? But the distortion more and more for the inefficient one. So that is the main result, right, of this type of model. Let me quickly talk about application, okay? Because since here we have many applied people here, so let's go to application. Okay, so maybe I have a break, right? A little bit too long. So before, I'm not going to talk about model that I talk about after break, but I'll tell you what are we doing. Okay, from this model, okay, in particular, I'll talk about the bank loan. Okay, and later you will see. Okay, later I will go to that. Okay, it's the financial contracting. I don't know whether the one who tried to borrow from me is good or bad. Okay, at the end of the day, okay, I will try to distort the interest rate, okay, such that the poor type would find the interest rate very expensive. Okay, so that's why if you're good in the credit market, you're a good firm, you don't have no problem. When the firm is very small, it's some problematic thing there. Okay, so that's why it's always in the finance, it's always as a credit rationing, or what we call the the small and medium enterprise are difficult to get the credit because it's very inefficient, right? And it's also related to what we call price discrimination, right? And here talk about regulation. So you can see the model is where we just apply what we learned in different model. So the framework is general enough. We just reinterpret what's you, what's we after the break. You will see it. All the intuition carry through. Okay. Let's have a break of 15 minutes and then we can come back to it. We'll resume at 4:45.
我来确认一下，这个的意思是在这种情况下，那个高效率的人，他就是没有
拖下来，没有拖下来。
对，所以他可以装。
因为高效率的人，我会 design contract， 跟你跟那个 first person。first class
一样，所以这个不好。
不好，就是 this efficient, because it's good type, efficient type. You still do whatever you do the same as
the inefficient type.
You will still do as you would do. Okay, I design contract such that you would be doing as you would do if I know who you are. I design contract for you. 但是我防止你要 pretend 这个人，我就要让那个比较 bad type、low type、inefficient type 的话多少一点，就不用 pretend。
就是你给了他一个额外的。
对，但是其实你给我给多点钱 ，I give you 多钱 ，I give you a little bit more。
你讲粤语，说不定我。
So， 個意思就係話咧，我要俾多啲錢你，咁你就唔會裝扮佢啦。即係話，我俾咗多好多，我俾咗呢嚿錢你就唔會扮。即係話簡單嚟講就係話 efficient type to produce efficiency。Low type 就 all the surplus extract。
这个是那个啥是吧
？Low type 就係呢個 efficient。
就是這個是。
Low type 嘅 brand 它就用呢個 positive。efficient 就什麼都沒有。對，比較習慣。對。就背着来看。我发现很多种 model 非常多，今天电脑有大家反正考试比较多，都会这种类似。Fear corporate finance。
还没开始上。
那个整个书就在讲。
我听说就是 corporate finance 跟 cultural theory。
现在就是这种。
Estimated information。
对，这边就是这种，就是 IR constraint 和 IC constraint 以后，抓一大堆对不对？
我还以为会跟那种什么 governance 相关。
government 的教学的教学 ，corporate government 这个，比如说为什么他们有 over 就是有些 debt， 为什么要拿 debt rather than equity 啊？很多都是这个 contract， 包括这里面，为什么 debt contract 和 equity contract， 很多教学都是这样。很多内容，之前就拿的。基本上节目都已经解答了，assume 一个 constraint 来源。我天天能节目是。
好闲呀！
但是这个 information 的话，在 economic design， 在 economic design， 包括 design， 怎么决定这个，比如说你的东西就这个。
一般都不只是不语。
OK， 这个 emission 啊，这个 gas emission。不同的医生，不同的方法。
但是现在那种政策不是还挺易盗窃的？
它有大的小，大的 firm 的不同的公司，在说
所以你的偏见是什么思路？哎呀，
这是这个
基本的心理
什么意思啊？
我的经理
反正多少？
不扣
非常花钱。
8年，
哦，我听见8年了，吓死我了。
8年。那我们
还挺顺利。
对，我说的是 share， 就是那个river sharing， 或者说要和。
我们之前做了一个合掌这个实验，然后也投进，然后境外省，然后被拒。
那就是一个合理的，理工合的，就是那个。
你用的是理工好。
理论检查上。
我们用的是跨省合流。
所以跨国家的合作，比如说合的上游跟下游。上游跟下游就是上游可以决定要不要给水利再去。
那你这个我们也很想要做这个实验，来证明这个事儿，然后整个人说他觉得合掌这个危险，就是会让这个引力维护现象会更少。他不相信这个结果。
有说怎么去更加好的那一个是要的。
怎么更加好？
我们就 propose 这个 mechanism， 第三那个 game。
跟这个有关？
不太一样，这个是东西 concept 也是一个centralized mechanism， 比如说大部分去第三这个东西去要企业去做 centralized， 但是我最近做的东西都是 decentralized， 就是说这个 game， 这个东西是 game， 所以说那个公司决定怎么打包的话。公司说要什么 contract， 他给了contract。
那这个不是下面是可以？
而且这个bargaining power 就在这个里面。但是你不在合流的话就没有政府。合流的话是国家意见的，哪里没有跨国的没有办法去有一个比较的影响。UN 是没有压力的，没有他的，所以必须要就是国家自动愿意参加的。
那你们的那个
就是上游给一个分手的 analysis， 他们说的给他们说 分区8个里面说员工只
我上次看到就是那个像这种 international 的话，德国的话就是可爱，或者那个屁股光头的，太可爱了，我看到过大的人穿。
你没有麻烦，那手表很便宜，后来跟你上就。
那下一次会讲讲你的那个。
我的想法，我就个人，可能咱们不讲的话，在上8个课，但是还比较难。
下一节课，不是，我是说，就是下一次课。
比较难。
所以每一次读课都要讲这个内容，讲完就该。
我希望讲完我还再讲而事情呢讲一点，你再讲，还要讲一个包括什么？包括什么？再有时间我们讲那个你的，如果还有时间的话，我讲一讲一些现在的。8个人地，我8个人，8个人，就无所谓，就把所有的，为这个就在累一点啊，
这个感觉能套到很多业务去，包括管公司啊，
对，把我们为什么吸引不会？
这个问题是还是很受到关注的，然后到了大部分公司，这个晚会的话，
对，我觉得你这个
不给的话就是888。
感觉这个能套到那个所有代理问题，就是公司
对，所以代理问题不就是说他，就是说他想要的是到的风险，几乎是没有什么，那就是这个是去年就是经常很多没有的。
所以你平时只看活动，看是什么？看 model 的时候你会推一下，还是只看他们设定？
推一下对。
不看他们的包装。
对啊，很晚期。
就是我发现 iPad 上有文章，他用那个什么联邦学习的那个东西去包装这个材料卡，就那个真是太厉害了。
对，这个实际的把握的好的人才包装好受不了。你要对原我是要属的，是要脑公婆的。你说你用我密码可以的。
我刷到过同样的睡衣，睡衣不是太可惜一点，因为是躺着。我也是，是吧？我感觉下午上课好累呀，就是先困，好不容易醒了，开始，然后肚子开始叫，很尴尬，笑死了。
最近网上我美团在香港批卡那个外卖平台的，我怎么没看？我老刷到这个广告。然后我楼下那个我公寓楼下有好多就这个外卖，大家想取，便宜吗？然后 IP 我下载，我希望它起送能低一点。对，它老起送100，我哪里给得了100块啊？对，确实，我有这个困扰。可以公寓凑单，我们宿舍经常有凑单，但是我都不凑。就是我
加了一个人，因为之前跟他一起点了外卖，但是他老晚上吃饭，我晚上不想吃饭。
So before the break, we talked about the efficient contract of Morhasa, but let's review again because we will apply this directly to many applications, and you will see this model is, I think it's very useful. So let's go back to the beginning, and then, so remember what we did is the principal and agent, okay, and the surplus over SQ, and that will be the model, right? And how we solve it is because the principal can design a contract, right? The contract can be anything, but because we can focus on these two contracts, right? Because they will accept this contract, right? We assume the subgame actually they can implement this one. Why? Because T is continuous, right? We can make T slightly more than epsilon, then make this IC strict constraint, right? So that everything will be implemented as we want, okay? And particular, what we see in this model is the more efficient type, okay, are produced at efficient quantity, but you need to pay him extra compared to first pass, right? Because you always need to compensate him, right? Because by pretending, right, that's what he gets, right? So that's why he always give some, earn something anyway. So you have to give him some surplus, right? And the inefficient type cannot earn any surplus, okay? But you need to make him some distortion. Ask him to produce less than the efficient level, okay? And that is what we have, right? So let's repeat the conclusion there is efficient type is earning some information rent, which he supposed to extract all the surplus under complete information, okay? And he got paid more than the complete information one, right? And he produced as in the complete information setup, okay? So it does mean that sometimes you see the CEO payment, right? The CEO actually get compensated a lot, right? Because the good type actually pay them a lot, right? In order to make them do efficient thing, right? That is the main result. But let's see the application because we see this. You can just rewrite what U was T was Q, then you will get what it means, okay? So you can see this is usually what you would see is regulation, okay? There's a model where government try to regulate the firm, okay? It's a monopoly, right? You can imagine oil company in Hong Kong, electric company, right? So the government try to regulate that, right? And the slightly different is there is a 1 minus alpha U, right? It's costly to left the profit to the firm, right? Because you care social surplus a little more, okay? So in that case, you would make this assumption there, okay? And you can actually solve it showing that the efficient type is still do efficiently. The inefficient type, okay, you have some inefficient component there, okay? And this component related to the difference of the type, as I said, right? If this is go to 0, this is actually go to 0, right? And The other way around is look at this is nonlinear pricing, right? That's called the price discrimination, right? That's Maskin and Rennie, right? This is a very standard when you look at literature. People talk about this, is Maskin and Rennie. Okay. One seller and many buyers, right? And marginal cost the same, right? And people get the payoff is depend on the type times how many quantity they have, right? And this model, the information range like this, right? Nothing new there. The IC constraint is same as what we've seen before, everything is same. Okay, and by rewriting this, right, by solving it, basically say the high type, the good type, right, high value type, get efficient production. The valuation low type get less product. There's some distortion there. Okay, and there's some benefit being a consumer that is more willing to pay. Right, you get some surplus of that. So that is the model. Right, you can actually solve everything there. So since two of you here are the finance, right? This is same as the same. This is another paper called in Massa and Rosen. This is also very famous. Okay, just principle have quality choice. See? It's quality discrimination. That one's quantity. This is quality, and everything the same, right? What you would get is the model is similar, right? Same as what you see, right? And what you get is rich people get what they want, right? But poor people get much lower quality. That actually explains what we see in the world, right? The economy class, the ticket, the position is very cramped, right? They deliberately make the economy product as worse as they can be, make that want you to take the premium one, right? So that is the idea there, right? So that is what given you here. Okay. And lastly, as I said, is financial contract, right? Is you have the lender, right, and then borrower, okay? And lender, the payoff is very easy, right? How much, okay, you are giving, the lender is going to lend K unit of money, okay, and ask for a return for T. You can imagine this is maybe hedge fund, okay? I'm going to give you K dollar, okay, and you give me back T, okay, and R is the cost of capital, right, for you, because this determines also option, okay, and this is the startup, right? Startup is more productive, you get more capital, and theta is the efficiency, how you use it, which is private information, and T is the one you have to give back to the principal. Right? So you can easily see everything the same as the model before, right? You can actually solve the IC, all the constraint there, right? So this is hedge fund investment model. And what you get in this model, as you will see, is the efficient type, good startup get what they want. But not so good startup doesn't get what they want, right? You have to make sure that the good startup get everything, but you have to distort, right? Make the not so good startup doesn't get what they want, okay? And in order to maximize profit, okay? And that means that's why this is a private solution, right? So that's why the government right, would need to subsidize in order to make this better, right? So usually the good startup will be funded by private sector, right? Not so good startup will be funded by government, right? In order to this happen, right? The good type has no problem, right? Always no problem. Okay. Now we talk about the other model, moral hazard. Okay, don't worry, actually moral hazard is easier, even easier. But because so easy, we make more complicated. The model is very simple. Okay. In general, moral hazard is very complicated. Okay. But we focus on hidden action, right? Because type is either one type or two type is easy. But action, you can do a lot of stuff. Okay? But we make it easier because we just ask whether the effort is 0 or 1. Okay? And the cost of effort, we normalize. If you don't do effort, 0 cost. If you do effort, you just phi or psi, right? Psi. Okay? And the utility of agent would be U of the payment, okay? T is the payment, and how much effort you do, right? T is the payment, sorry. T is the payment. Okay? And do note that we require U of T is like this, okay? Increasing on the money, right? Increasing and decreasing rate. Okay? And we'll define H will be inverse of U, which will be clear later. And what is moral hazard here is, I can't observe, it's a standard model, is I can observe what they produce, which is observable, but I can't observe the effort. So the standard thing is like firm and worker. I can observe how much the agent produce, but I can't observe the effort. Okay. The problem will be, in general, we can say, okay, why don't I use piece rate? Right? How much you produce, I would just pay much. Yeah, that's fine. Piece rate is one way to solve this problem. Okay? But sometimes we actually you don't know what should be the rate to induce them to work. Right? I just want to make sure that they work regardless of whether outcome. I want to reward the input or the output. Why? Because agents are risk averse. You ask them to do the piece rate, you make the worker assume the risk. Why? Because the worker don't want to take risk. Right? You ask them, or look, as a firm, I want to look at output. Right? I just get the output. In that case, actually the worker take the risk. Right? The worker, because production is stochastic. Right? Is if you work, you're more likely to have better output. If you don't work, you have less likely to have output. So if you say I do the piece rate, it's not very efficient because worker take the risk. If the worker is risk neutral, okay, that's fine. They don't care, right? But in general, this is not optimal. Later you will see, not very optimal, okay? And you will see actually it's better if you try to reward, try to make him work harder rather than look at the output. So you make sure that he put the effort, you reward the effort. Try to reward the effort. Okay? Make sure that he want to put in effort. Right? You will, okay, later you will still do a kind of piece rate, kind of non-linear piece rate, but you want to make sure that he put the effort. Basically, it's just piece rate based on effort, non-linear piece rate, but implicitly you want to make him the effort. Okay? Because you only can reward based on the output. Right? But I want the piece rate such that he want to put in effort. Non-linear piece rate. So output is stochastic. Okay, this is measuring some kind of information asymmetry with delta Q. Okay, here is that I don't put in effort, I still got good output is pi 0. Okay. Pi 1 is I put in effort. How likely I get? Okay, the low output, is it wrong? I think it may be wrong here. This is a typo. Typo here. Is pi 0 is don't make effort, high output. Pi 1 is make effort, high output. Okay. Sorry for the typo. Okay. And we assume pi 1 more than pi 0, that's natural. Okay. And in general, this actually, you look at the literature, that's called the monotone likelihood, which means that the more costly action, right, put the effort, actually make more likely that you would generate more output. Okay. So we want this to be positive. Okay. So the contract is very simple, right? Again, is I observe the Q, right? Observe the output. I want to have a nonlinear piece rate, right? This low output, I give, sorry, typo again, right? Low output, I give low payoff. High output, I pay high, sorry. Okay, so that's what he said, right? T can be negative or positive. Okay, so I just have two, okay, set of contract. Now, for the principle, this is very simple. If you put the effort, the well is in pi 1 and 1 minus pi 1, right? Pi 1 output, minus pi 1 no output. So just 2 points. That is the expected profit, right? You have output, this is the payment, right? This is what you earn, right? If you have put the effort but still not successful, low output, low payoff, right? The only thing that you gain is from jump here to here, right? You induce the effort, right? You jump from pi 0 to pi 1, right? There's a gain of doing that, right? You induce the effort, more likely to successful. Okay? And to save notation, S upper bar is surplus when you have high output and lower output. Okay? So that's, yes. No, S pi 0 means if you don't put effort, you still have high output. So that's why I said the notation is, this is correct, right? This is what it said, right? You don't put effort, high output. So this is upper bias here, right? You put in effort, high output. Okay, sorry for the typo here. Although this set of slide I have done it 3 years ago, but I never able to talk this, so that's why there's a sorry for a typo here. But I hope now it's clear what I mean, right? So very good you ask question. So hopefully that everything is there. So that's very simple, right? Again, it's a little slightly different, right? First is because there's no uncertainty in this model, right? Nature doesn't work in this model. The nature only works in output, decide high or low, right? First is the principal decide the contract, okay? And agent doesn't only take the contract and then do the production. And the nature tells whether you got a high output or low output. And then output realized, contract secure, right? So again, the only main thing is T equal to 0. Everything is straightforward, right? There's no game element there, right? Because we assume that when the agent take it, they will just always exert effort. Okay? Because the thing is, if the agent doesn't exert effort, then there's no problem, right? If I don't want agent to exert effort, then I just don't pay him anything, right? So that's very simple. So that's why that's trivial anyway. So we have two constraints, which is trivial. Look at the below one, very simple. I want him to do effort, then go outside, right? Do effort, you have pi 1 successful, 1 minus pi 1 successful, cost of effort bigger than he stay out, right? And this is, he put in effort is pi 1, he don't do is pi 0, right? So I want him to do effort, then no effort. So you see the constraint is much simple, two constraints, right? Because only one type of agent, right? Effort, then no effort. Effort better than get out of business, right? Better than accept the contract, right? This is accept the contract and do the work, right? That's the two constraint there. Then you can see it's very simple, right? I just choose payment for you have output, you have low output, right? High output, right? And I want this to happen. Okay, this is the constraint. Okay, and to solve this, of course, you can use conductor, but this is very easy to solve. Why? Again, payment is costly to the firm, right? I want to reduce it as slow as zero as possible. Okay, so this appears on the left hand side, right? On the right side as well, right? This one, okay, if not zero, so you suppose that RPC is not zero, it's not strict, bigger than 0, okay, then I can always reduce this, my profit improve, right? And if I reduce this also reduce, right? And suppose I reduce this guy, P upper bar, right? Remember, this is bigger than this, right? I reduce this, right? This constraint still hold, right? So that's why I can reduce that. I can also the same reduce this guy as well. So this constraint must be binding, right? Because this is have more leeway than this one. So, or you can put it this way. Let's assume they're binding. You solve it, check it, still binding. So must be binding. Both are binding. Put it this way. If this is straight, you can reduce T upper bar here. This is still hold, right? And this reduce both, right? We're still holding. Okay. So first, let's do it this first, okay? Suppose they're complete information, right? That means that I know who they are, okay? And IC is not constrained, right? Because I know effort, okay? That means that I just choose this guy directly, okay? I just have, make sure that they want to do whatever they do, just extract out the surplus, right? Basically, if I have the IC, so I know the effort, right? So basically, I would say, if you don't put in effort, I give you nothing, right? Then that's done, right? Basically, I can make T lower bar is 0, right? I don't pay anything, right? But anyway, this is the thing, right? You just, because equality holds, you just put where the Lagrangian there, right? And once you solve the Lagrangian, okay, now go, you can just differentiate that guy. Turn out that you do the same thing, right? So what does that mean here? Okay. Go back to before. Okay. Here it means that you are going to observe it, right? So you would try to make sure that he put an effort, right? So no matter there's a result or not, you pay the same. You pay fixed wage, basically. Okay? You pay a fixed wage, regardless of output. As long as put in the effort, you pay him, then he will do the effort, right? So let me repeat, it's a fixed wage contract, right? Because I know he's doing effort or no, he's doing the thing, right? So I would just basically pay him the same, right? Because I know there's effort there, okay? And the payment just enough to cover his effort cost, right? T is h of mu such that I pay him just enough to induce effort, right? Let's make him indifferent of or not, right? Because if you don't do, I can observe effort, right? If you don't do anything, I give you 0. Okay? If you do things, I pay the same. Is that clear? Okay, the idea is look at the Lagrangian, why this is true. If you increase the payment for good outcome, right, you would reduce this money, right, because you pay more dollar, right? Your payoff is less, right? Because actually you pay more for the good outcome, you have your profit will reduce by pi 1 times this one, right? So the amount, the condition is you get less, right? And similarly, if you get this, you get less for this one. But what's the gain for doing that, right? The gain from doing that, look at this one, right? You increase this, right? You increase the utility of the agent, right? Basically, you balance your payoff and his payoff, right? To induce them to work hard, right? Because remember, you have to follow this guy, right? Make him 0 payoff, right? Because actuarial surplus. So which means that if you increase your payment, right, you kind of relaxing this one. You increase your T, you actually relax, make this bigger. Then you can lower the other one, right? So the benefit of increasing the payment for the high output outcome is you can lower your payment on the bad outcome, because on average the surplus of the guy is 0. Okay, so turn out that, okay, because of the U prime is increasing decreasing rate, okay, this is same. So in the other word, very simple, is U double prime is concave, right? So that means the agent is kind of risk averse, right? Or marginally distributed. That means that you want to give him the same thing, though he's very happy, right? So that's why you get the same payment. This is the outcome. Okay. Basically, you are insuring the agent. Okay. Now, oh, sorry. Okay. The last thing is it optimal to induce effort? Okay. I'll finish it in 5 minutes. Okay. So here is the payoff of inducing effort, right? And this is not inducing effort. So the question is whether it's worthwhile, right? You compare these two, right? And you take the difference, right? This is the expected gain from effort, right? Because this is the surplus changes over the probability, right? Because it's in this effort, you come from S lower bar to S upper bar, right? And this is the probability that you change, right? Because putting effort in probability, right? So this is the gain of social surplus, right? Because this minus this guy, right? And this is the cost of effort, okay? And as long as optimal to do it, you would do it, right? Because it's complete information, right? As long as the surplus increase is more than the cost to induce him to do, you will do it, right? That's very simple because you know it, right? As long as payment to him is bigger than the gain as the principal, you will do it, right? Nothing new there. Okay. Let me finish this by the last slide. Okay. Sorry for a little bit delay here. Okay, this one. Okay. Now I assume risk neutral. Very simple. Risk neutral of the agent. Okay. It's this one. Ut is equal to T. Okay. And look at this model. Okay. I would argue that these two constraints are binding. Okay. First, look at this. The PC must be binding. Why? If not binding, again, I can reduce this to make this less, improve my payoff, right? And you just take a subtraction, okay, it still hold. Okay, put it this way, you can always reduce the payment epsilon for both and doesn't change anything. Okay. The second is the same. If this is binding, this is also binding as well. Okay. So that means that it's very simple. Okay. If this is binding, the constraint is the solution. Because this is equal to 0, this is equal to 0, two equation, two unknown, you are done. You don't even have to solve the maximization problem. Right? Because two constraint, two unknown, either you have solution or no solution, right? Because the constraint is the only solution is T upper bar to lower bar. So that's it. That is the solution that we're done. Very simple, right? So the lower bar, right? Two equation, two unknown, right? Set equal. Solve it, right? And turn out to be very simple. Is the lower bar, the low type, you use the stick, you take away the money. If they do good, you give carrot. So this is carrot, this is stick. Okay? What we're doing is, if you do good, I give him carrot, I give him some surplus. Okay? And if you do badly, I stick Okay, but of course, as an agent, the average is the 0, right? Because remember the PC condition, right? So you're doing well. If luck, I put effort. If luck happen, I get something. That I got stake, negative. Okay, I got punishment. Okay. In that case, that means that if I luck, I have some positive payoff. I'm unlucky, I got punished. Okay? And in that case, as an agent, for me, I do the effort, I improve probability. This is the extra payment I get, right? This is the stake, right? This is the carrot, right? And this is effort, yeah? And that is the model, right? Very simple, right? Basically, it's just like, okay, the model is like, if you do well, I pay a lot. If I don't do well, I have to punish you, right? And probably ask, is there anything that happened in the real world like this, right? Yeah, kind of. If you don't do well, you just get out. Your boss will make you trouble. Yeah, the same. And this also happened in the old days in the 90s. Actually, when you go to the management or financial management, you need to pay the bond. You pay money first, and then if you don't do well, they forfeit the bond. Like this. Okay, you are or yeah, something like that is a problem. Okay, but probably you ask, you are not allowed to ask money from the agent, right? And actually later I will talk about next makeup class is what we call limited liability. This is bounded by 0. Okay, and I'll talk about later, but you will see if I have to say the T cannot be negative, this is 0, special case. Okay, and the model will become slightly different. Okay, but the thing is, if I allow the stake happen, okay, this model, you should solve it. You can induce even the moral hazard. If I allow the stake to happen, I can have efficient outcome. So moral hazard is not a problem. Okay, and indeed, this is same as I sold the thing to the guy, right? This moral hazard, if I don't have, but I don't have the limited liability, same as a firm. I basically sold the project to you. Okay, you take the risk. Yeah, the outsourcing, right? So they basically outsourcing to you, right? You carry the loss, right? You handle it. I'm not going to, because you are risk neutral, right? I basically sold the project to you, right? You pay me this much. If you gain this. I don't care about it. I no longer care about that. So this is the same as just like when there's risk neutral, right? I basically give the project to you at the fixed cost. Okay, you just pay T lower bar to me, right? Same as that. But anyway, we can talk about this next class and what happened in the liability, what happened to the risk averse agent, and related to other contract as well. Okay, and we can talk about some more fun next class, but we'll see you next Monday. Okay, thank you.